class. All right, well, this is electricity 1. Very, very basic. Mostly it's designed to give you enough understanding so that when you're running trains, you really understand. Are you here for the class?
I can sit here and listen.
Okay. So that you understand what the difference between a short and an open is. And that's as far as we're really going with electricity tonight, to any great degree. I'll answer any other questions, but that's the main thing we're going to be covering here. So what we have here is, we have a power supply over here that's feeding power to this little board I made up. And we've got, this is a tail light bulb, just like we use on the mainline cabs and stuff like that, that is used to limit how much current can go out to the locomotive. But that's not really very pertinent to the opens and shorts, other than it will light up when there's a short, and we'll explain that. So we have electricity coming through the bulb, goes through a switch here, which at the moment is open. As you can see, electricity can't go from here to here, it gets here and stops. The other wire is just going to the meter so that we can see what the meter is doing, or what the voltage is. And then we hit from the switch, we come to another switch, and one side of that goes to the motor with a little flag on it here, and the other side goes to the other side of the switch and off to the amp meter. And unfortunately this motor doesn't draw much current when it's running, so it's not going to make the amp meter move a lot, but it will move. And then the power returns to the power supply. And electricity is a lot like water. Voltage is equivalent to how much water pressure you have, and the amperage or the current, that's analogous to how much flow you have. The only difference is the water starts somewhere where there's some pressure and goes to some place where there's no pressure, and we don't care what happens to it after it gets through the system. With electricity, it's got to make a complete loop. If you start pushing electrons in here, if there's no place for them to go, electrons won't come out the other end of the circuit and nothing happens. The only thing that happens is the voltage will be the same in both places, but there's really nothing going to happen. So when you plug in a block or do something like that, or throw a switch to turn on something, that's like closing this switch here. You see a little motor. I'll turn it down for a bit. It doesn't need to go that fast. So that would be our train running, and how fast it goes is proportional, directly proportional to how much voltage is on the track. So as I turn the voltage up, the motor gets faster and faster. Turn the voltage down, which is like turning your throttle down, that turns the voltage down, it goes slower. You go slow enough or low enough voltage, and it'll stop. Where's the fine one there? There. And we still have the, it's hard to see, but there's actually still a little bit of voltage there. There's about, according to this, there's 2 volts there still. But this is like when you turn your throttle up, at first the train doesn't go, but you get a little higher and then it starts to go. As you can see, this motor is very low current, but it probably doesn't draw enough to really even move this amp meter. And this is only it's a 6 amp meter, so it doesn't. So anyway, if your train stops, that's an open, or it could be either one. But if you have lots of voltage still, you've got voltage and no current, that's an open. And as you can see here, the switch is open, and that's why we have an open here. So we do not have a complete circuit from the power, from one side of the power supply through whatever's controlling it, to our switches, the motor, and back. It's an open circuit, and that's why we call it an open. An open can be caused by anything from you forgot to plug the block, there's dirt on the wheels, the locomotive's jumped the track and it's not even on the track, or you're not in the right block. Anything that prevents the electricity from making a complete circuit around is going to be an open circuit, and nothing's going to happen. It's just going to sit there and look at you. Now, if it's running, the other condition you can have that can be a problem, and I'm going to turn the voltage back on here so you can a little more, is you get to we have to have a little comedy. And Yoki's buddy puts a quarter on the track, or something happens and your locomotive jumps, the truck drives sideways or wheel comes off, and goes from one rail to the other, boom, the motor stops, your train stops. Now you'll see the voltage has gone to zero because there's a direct connection across our load, our motor, and with the short, voltage goes to zero, and now we have current here. In this case, we have about 1.5 amps that's flowing through here, and the reason this light bulb lights up is a safety thing that we do here at on the railroad, so that if we do have a short, rather than drawing 10 or 15 or 20 amps, whatever the transformer upstairs could provide, we have a tail light bulb in series with it, so that the more current you draw, it starts to light up. And it's a...
I think you burned it down.
You broke it.
Yeah, I think I burned it out.
Yeah.
No! Hey! Now you have to film it with fire.
Yeah. Yeah, we'll open it up. So what happens is, upstairs in the electrical room, we have not just one bulb, but a couple of big taillight bulbs that are wired in between your throttle and the layout out there. And what that does is, if there is a short, the light bulb will start to burn, and the light bulb is not a typical electrical item, that the more current you put it through it, the higher the voltage across it is, in a very linear fashion. If you have a resistor, you have a piece of wire, most everything electrical, if you double the current through it, it's going to double the voltage that's dropped across that. Two things are different here. The light bulb is different in that the light bulb is not linear. You can draw, in the case of upstairs, up to almost 2 amps, and the light bulb doesn't really start to get bright. But once you get up near 2 amps, then as the light bulb gets hotter, the resistance goes up very quickly. And then it limits how much current can flow all the way from the power supply for your throttle all the way down to the track and back. So it's sort of like a circuit breaker or a fuse, except it doesn't open the circuit. It just limits the current so it doesn't fry your shell and your locomotive by generating a whole bunch of heat in the locomotive. You can still generate heat if it's a plastic truck or something and it gets just right and the axle gets somehow shorts out and gets hot. You could melt a side frame or something even at 2 amps. But normally, unless you leave it running for on for a long time, it's not going to generate enough power to really damage anything. And the nice thing about the light bulbs, if we put a circuit breaker in there, it'd get up to the 2 amps and the circuit breaker would pop, and then you couldn't easily fix it. Somebody would have to go back and reset the circuit breaker. If we put a fuse to do the same thing, we only have to replace the fuse. How many times a night would we do that, I wonder? So we call it a ballast bulb, and all it does is, normally at a low current, it's so limited in its resistance to electricity that it's like it's not there. But once the current gets high enough, then it starts to heat up, and the more it heats up, the higher its resistance goes very quickly. It's not a linear function. So if you double the current through it, depending on where you are, it may increase the brightness by 5 times. You know, it's not proportional to how much current goes through it. So you can see we're running. And that's basically the difference. Now with the short, as I was saying, when you short it out, what happens is you see the bulb is very dim because I don't have the voltage up very high right now. So it's very dim. So the current isn't very high. It's only half an amp right now. If I turn the voltage up, the amperage goes up a little, but you see the light bulb gets a lot brighter. And that's about 1 amp right there. We open it up, take the short away, and the motor. So why is it called a short? It's called a short because it's taken the path that we wanted the electricity to go down here, through the motor, and back the way around. The motor's doing the work, running the train. But if something gives the electricity a path where it doesn't have to go all the way to the motor, it can jump from one rail to the other, or if you're across a switch and it's thrown against you, it can feed through the frog transfer on the switch. Anything that allows the electricity to bypass the motor and find a shortcut, basically, will stop the motor, make the current go up. So that's why it's called a short, because somewhere between your throttle and your train, it found a shortcut. It found some way to not go to your locomotive. Now, could get to your locomotive and just be a short in the locomotive even, but somewhere between there and the motor, it found a shortcut that it could take, because it's always going to take the shortest path it can, the path of least resistance. It tends to be very lazy. So if you give it a short, that's where it's going. Once you fix the short, things run again. Again, if we lose the connection, it stops, but the voltage stays there. So if you've got voltage on your meter and your train isn't running, you should see that your current's at 0, and that's an open, because you've got voltage, but it's not getting to the train. And that's caused because the circuit is not complete. You need to close the circuit by plugging the right block, or putting the locomotive back on the track, or getting the yard master to throw the right track, whatever it might be, to complete the circuit, and then you go. If you get the short, watch what happens to the voltage. Boom. It goes to 0. You may not go entirely to 0, but it's going to go very low from where it was when you were running. So when you've got a short, it's taken that alternate path, and the short has almost no resistance, so there's going to be very little, or if any, voltage lost across that shortcut. And that's why the motor stops, that's why the current goes up, and why the voltage goes to 0. In this case, the power supply is still putting out the same voltage, but it's all getting wasted in the light bulb there.
I think
That's a flaky bulb.
your connection is getting
Got a
used.
loose filament inside it.
Yeah, I'm sure it's in the filament. Short goes away, things will run again. That's the really nuts and bolts, basic of what's going on with the electricity when you're running your train. So does anybody have any questions about shorts or open or anything else related to it? I'd be glad to answer.
In other words, high volts, no amps is an open.
Yes.
No low volts, high amps is a short.
Right, so if you think of the short, that's when there's A shortcut, short circuit, that's when the amps go up and the voltage goes to zero. If the throttle's working normal and you get lots of volts but nothing happens and the amp meter doesn't work, you get no current, you've got an open. You might have detection, but that could just be your caboose sitting in the block. But the locomotive might be either in another block, or a wire's gone open in the locomotive, or it's jumped the track. Can't tell you from the meters what it is. That's why you have to go call the track walker to go see what's going on. Why doesn't my train go? But it's important to let him know if it's an open or a short. Same if you're asking somebody to help you. You need to, understand an open means that I got voltage going out there, but it's not getting to my motor for some reason, because there's an open switch somewhere. There's an open something in the circuit. So I don't have continuity, so I have an open. If I have no voltage, then I've got a short circuit. You'll turn the throttle up and you'll see the meter, it may move a little tiny bit, but it doesn't go clear over to 20 like it does normally if you turn the throttle all the way up in the cabs. And this applies whether it's a cab in the main line or in a yard cab, though not all the yard cabs at the moment have functioning meters, but yes.
John, I've noticed sometimes when you're running a train up there in the cabs, if you shut your power all the way off, sometimes that meter is going down. It may show like 1 volt or something on that meter, still on the, it doesn't go all the way down to 0. Is there a reason why it does that?
That could be just static on the meter. If you
open.
take and go polish the top of the
Usually
meter,
you're open.
you can make it go up several volts sometimes.
If you're open, if you are-
That's like fake detection.
If you are open, it usually shows a couple of volts. Like if you're
If
coming
it
out of
open,
the
it's
yard and he hasn't
oh,
given you the
well,
track yet.
if you're plugged into a block and you've got it open, you may see a little voltage indication because there is some AC voltage across the track for the detection circuit. So you may see a little residual. But if if you turn your throttle up and it hardly moves, it doesn't go up to whatever voltage you'd expect to see. If you can turn it all the way up to 20 volts and nothing happens, you've got an open. It may not go entirely to 0, but that could be either because the 0 on the meter's off, it could be that it's static on the face of the meter, it could be you're plugged into a block and you're actually, getting a little false indication off the detection, which is about 2 volts across the track, and but it won't respond. If you've got an open, the throttle will respond. It'll go up. But if you've got a short and you do that, the voltage is not going to go up. But yeah, you may have a little residual at the bottom. I haven't gone through and made sure all the meters were zeroed in several years because they normally don't wander off much, but they can. But yeah, so it's just stray voltage. It's like if you have a volt-ohm-meter and you just put it on a piece of wire someplace. You may measure something voltage-wise. It doesn't mean there's really anything there. You put your fingers across it, you're big enough to act as a short and kill it. It's just induced voltage from all the electrical wiring in the building or wherever you are. But there's no power behind it. Any other questions? Anybody wants to come up and play with the little demo up here, well, you're welcome to. Ted?
Some of the newer DCC decoders have kilo lives, so you may see some residual voltage out of those when you shut off.
Oh, it will backfeed?
I think so.
That's possible. That's possible that it can backfeed.
You may not see it in DCC mode, but you might see it in R mode.
Yeah, possibly.
Does electricity just flow anywhere until?
What's that?
Does electricity just flow anywhere until it goes into the right spot? Or no?
Let's speak up a little more.
Does electricity flow anywhere until it gets into the right spot or no?
Electricity can flow anywhere where there's a conductive material. Basically the wires are the conductive material we use to get electricity from one place to the other. but electricity will flow through a wire, through a quarter, through a screwdriver, through a knife blade. Basically, any piece of metal will conduct electricity very well. Silver is probably the best, but copper's the affordable best. But gold, steel, zinc, anything made out of metal will conduct electricity.
Which is why it's a good idea not to go poking your fork into a 110 outlet.
I don't think I want
Or
that.
scissors.
The
What about you?
one, this is really beyond the scope of this course, but just as a note, some of the older, like Athearn or roundhouse locomotives that had metal frames with metal coupler pockets. If you have two of those and you want to run them back to back, you can have a problem, because the way those early locomotives were built, the frame picks up from typically the right-hand rail when you're going forward. Well, if the one is turned around running backwards, that means it's picking up from the left-hand rail. And if you've got metal couplers with metal coupler boxes, you end up with a short between the two locomotives. And what'll happen is, usually, they'll run a little bit, and then they'll short, and the current will flow through the knuckles. And of course, it doesn't always decide to go through the pin in the knuckle to the coupler. No, it says, oh, because they scraped and it's got lots of tension on it, I like to go through the knuckle spring to get from the knuckle to the body of the coupler. And then it proceeds to fry your knuckle spring, and it takes all the springiness out of it, and now it doesn't work very well. Once you compress it, it stays open. That's a sideline. That's well beyond this course. Chris.
So if the club mandates KD number 5 metal couplers or equivalent, how do you solve the metal frame to metal coupler problem?
You have to put in an insulated box. You may have to machine off on an old one, you may have to machine off part of the coupler box and then put a KD box in there so that it's insulated.
And that's why KD actually made plastic shank number 5s.
Yes.
They don't carry them anymore, but they
Oh, they don't even make those?
I don't-
They
I
do
don't-
make some plastic KDs that are plastic shanks.
The 20 series and the 30 series are all
Yeah.
plastic.
And that's to solve that problem. But particularly with the longer shaft ones, if you're putting them like through a snowplow or something like that, the problem is they're not nearly as stiff as a metal one, and they're very likely to droop just naturally or with age. If they get warm sitting someplace and it's sitting there, the plastic is likely to take a set and droop. And that's why we don't particularly like plastic couplers here. On a short shanked one, it's not going to be nearly the problem.
Hey, John, I have a question, if anybody's interested in that. How does purpose of a reverse block work?
Oh, now you want to get into
Technicalities.
101. Yeah, you can shut it, if you want, shut it off, or you can keep it going and you guys can edit.